In this video, we are discussing the asynchronous version of the energy of a bouncing ball lab. This lab consists of two components, the first being analyzing a provided video of a lacrosse ball bouncing. The second will be determining the coefficient of restitution of that ball and several other found objects. When analyzing the provided video, you will be doing video tracking, as we have done before, of the ball after it was released through at least 4 bounces. When you are doing this analysis, if that first bounce is moving a little bit too fast for you to figure out exactly where to click, that's fine. You can just start on when the ball is at the top of that first bounce, and you can start your analysis there of a subsequent 4 bounces. After you do that analysis, you will have position versus time data for that bouncing ball, but we need to convert that into energy data, and we will be doing that using calculated columns. Calculated columns are the means by which Logger Pro does math to existing data. So you could take position versus time data and then do some math to the position to change the position of the ball to absolute height. You could then take that height data and do math to that to convert it into gravitational potential energy. When you are using the calculated columns, the most important thing is that Logger Pro is very, very picky about the syntax of how things get written into that equation. You know how there are like 3 different ways you could have quotation marks? Logger Pro renders all of them the same, but only one of them will work. So to avoid all of that kind of nonsense, when you're in Logger Pro, you are never going to type words into the equations. You are going to use the variable drop-down menu to select the name of an existing column of data. It's just going to be a lot easier to use that drop-down menu instead of trying to type exactly the right name of the existing data set. In the second part of the lab, you will be calculating the coefficient of restitution of that video ball and several objects that you find. It doesn't matter if they are particularly bouncy, as much as they will bounce at least once. And when you are doing that, coefficient of restitution for your found objects, we don't care that much about exact heights. If you drop the ball from 1 meter or 90 centimeters, or it bounces up to 30 centimeters versus 33 centimeters, that's not going to be as important as being able to tell that this ball bounces up to about 1/3 of its starting height, this ball bounces up to half its starting height, this stick bounces up to 1/4 of its starting height. It's going to be that kind of an analysis, because then you will be explaining that behavior in the objects. Why is this object bouncier than this object, but not as bouncy as that object? Thank you for staying to the end of the video. Here's this lab's fun fact. On a hot sunny day, the Eiffel Tower in Paris can grow by up to 15 centimeters, and it always leans away from the sun because one side has thermally expanded more than the other.